that was all for today's paper.
All right. Okay, well, thank you very much. That was a fascinating set of papers from a variety of perspectives on sensing, behavior, and emotions. Let's start the conversation with the panelists. Let's start by asking some of the interesting questions about sensing. Like, let's talk about ground truth. Like, how comfortable you authors feel about the ground truths that you use, especially those of you who are using ESM or psychometrics, which are, you know, known to have like their limitations. If you use those as your ground truth, wouldn't that limitation be also carried to the model? Could you like speak about this, about this situation, please? Anybody who wants to jump.
I guess one of the authors that actually used psychological biomarkers could respond.
Yeah, that would be good. Yeah.
Yeah, at least in our previous work, the only thing that we could rely on were things related to the surveys, the subjective surveys that we took from the participants, asking about how they felt about a certain event at a certain time in their experience. I guess Marco might have better opinions on this.
Mm-hmm.
So it is always a big question about what we are measuring, and I think this community has discussed this like quite in detail, mm-hmm. and also like over the past like also through the interaction of psychologists and experimental psychologists that probably some are in the audience. I think so there is for sure, like now, in my opinion, like a better, so we acknowledge, at least some of us or most of us acknowledge the fact that what we are measuring is probably so the effects or correlation or causality in some cases of with respect to measurements that might not be completely linked to behavioral states, to emotional states, or or to emotional states. What I mean is the fact that we should be aware of the actual measurement that we consider, and in fact, like Victor presented before, so we were quite careful in referring to not to like emotional states in general, but to the dimensions of the tests, because it's quite easy to hype. To hype this field. I mean, it's extremely easy to say things that are probably not. I mean, being cautious, I think, is important here. So being cautious and being aware of what we are measuring is very important. So that is the lesson and the thing that I think we are becoming more and more aware. And I think that is kind of sort of, so the community is. So it's sort of like a maturation of the community in a sense, I would say.
Right. So actually following up on your perspective, and maybe for anybody else, like, you know, there's these two schools of thought about emotion, right? Ekman on one side, a linguistic approach of like putting labels on emotions, and then you have Russell and the circumplex trying to put like at least two dimensions, right, of arousal and valence, and try to pin emotions to that like quadrant. I feel like there's always contention between this perspective, and depends which school of thought you come from. It's like, you know, you will have to like pick a side and then eventually try to use that as your labels. But what you're saying is very interesting. Like, we're generating a lot of data, right? And maybe we can find like other dimensions, or maybe we can find other structures in the data that might reveal that traditional models of thinking about emotion like Ekman's or Russell are just not applicable, and maybe we have to formulate theory also, not just generate like, you know, measurement.
So one thing that is clear to me, at least like working with people in psychology and neuroscience, is that they are very open to listen to us, because what we are trying to, what we bring that they don't have is the experience of the real world. So the fact that we are trying to do measurement outside the lab and linking back to the lab experience and lab measurements is a big thing. So even debunking what people are doing, I think is quite important. Being cautious and respectful of like 1st century tradition in this area, but psychologists, at least my experience at UCL, is quite positive in that respect. People are quite interested in seeing what we do. And for that reason, I think we have also the responsibility of being very, like really paying attention to the scientific method and to like reproducibility, to be very careful in the measurements and so on, because the other communities are looking at our work. If you see all the papers about, I don't know, the smartphone manifesto, all this kind of paper in psychology, these are people that were looking at UbiComp.
Mm-hmm.
And they also say, oh wow, this is interesting, but we should live up to the expectation in a sense, I would say. Otherwise we lose credibility. Right. It's like doing like some works like, not saying anything about the neuroscience work presented here, but if you do work like, for example, with the helmets, these kind of things where it is very difficult to do measurement in the wild, then you lose credibility potentially, and instead like being careful, I think is quite important. Yeah.
Anybody else wants to chip in on that conversation? Should I start pointing fingers at people, raising emotions here, like you?
You should.
I mean, I would love to. Yeah, go ahead. Somebody's stepping up. Yeah.
Hi. I'm just going to point to my student now to talk about her response further. But I think this is true. It's very hard to just rely on self-report and ESM, just as what we've heard in the keynotes earlier this morning. So. And what we realized also, there was a lot of bias in the self-reports that we collected, even within person bias. So I think Nan can talk more about that as well. We will explore that further in the next paper, because we actually collected background survey and also continuous, frequent ESM before, during, and after classes. Nan, go ahead.
Yes, actually during my data collection, I designed year 5 golden standard questions related to the student engagement, and I found that yes, I agree that there may be many biases during for the self-report data. For example, the social disability. For example, students may always choose they are engaged in the class, or also I try to compare the response time during the participants, and I found that some students, they always spend longer time to complete the survey, and some students, they may use 10 seconds to finish the survey very quickly. So does that mean that their answer is unreliable than others? Yeah, actually we don't know. So yeah, in my future research, I want to explore the reliability of their report answers, because this is very important, especially in the human-based studies. But now at this stage, we don't have better solutions for the ground truth, because student psychological state is very difficult to measure. So I had to use a self-report measures.
All right.
Yeah, thank you.
Okay. Is there somebody else? Victor, you're going to say something? Go ahead.
Essentially, a sort of novice in this field, it's been quite challenging to sort of get to grips to like with the related literature essentially in the psychological domain. And I think, like, aside from the different biases that have been mentioned so far, what we found in our study, when essentially prompting participants at regular intervals, was that they very seldom completed all the questionnaires that we asked them to do. And essentially, it was quite rare that the participants would complete all those questionnaires at all times during the day. And from what we were able to gather, it was often the case that they were just simply busy, or if they were in a situation where it wasn't socially acceptable for them to participate. So there's also a sort of contextual bias, I think, that we're introducing here, based on when the participant is able to actually take part in the task that we have for them or not. So that was something quite challenging to deal with. I think more generally, I think there is sort of a dichotomy here between measuring something which is, I guess, inherently subjective, such as emotions, and sort of some of the some of the proxies that people have explored, which are somewhat more objective. But then it's also a matter of the designer of those measures baking in some sort of bias that would sort of translate, between these sort of objective measures that you can get through sensors and something a bit more subjective, such as emotions. So yeah, I think there are definitely quite a few challenges still left to explore in this area.
Okay, so let's talk about this. Like, are emotions objective or subjective? Like, are they? Like, as a matter of fact, I would say, we're actually breaking ground, as Mirko said, like, measuring a bunch of things that psychologists haven't been able to measure. Look at the types of sensors that we've been measuring here, like, intraoral, the head, there's so many things that we can start measuring. Like, what if we find out that emotions are like, less subjective than we thought, or they're more mechanistic, or maybe we already know that? Shouldn't we be constantly assuming that we don't know that, and actually when we measure these things, try to always do multimodal, like, ground truth validation? Or is this something that we should, like, discuss, as a community? Like, for example, if we're doing anxiety, we have the scale, but what if we also measure, like, the arousal tone, vagal tone arousal, through like some indirect measurement? What do you think about this, like, physiology, objective versus unobjective? Should we challenge ourselves to try to be more multimodal measurement for ground truth, or in general just multimodal measurement, or not?
Can I be heard?
Please, Jamie. Yeah.
I've been listening in on another computer, so I apologize that I've just seemed to have appeared. I've had technical issues. This issue about judging emotion, I think it's best done from other people. I think there is the subjectivity of it is so strong, and that's one of the reasons that we quite like this idea of what's the judgment of an audience watching. When you look at someone, you can tell. Getting back to the keynote earlier today, my self-report that I'm angry or anxious is probably unreliable, but someone else watching me has probably got quite the right idea that I've got. It's especially for the extreme emotions, and some people are better than others at judging the emotions of others. And I think it's having that multimodal approach would definitely help. Having multiple people being your ground truth, and then certainly if we're trying to sense this stuff, multimodal's, I think, the only way to do this. And we'll never get it quite right. It's a very human thing. And it's, I think that's what makes it interesting to study.
Right. And anybody else wants to chip in?
Can I
Like
go on?
Yes,
okay,
please.
Okay, so I wanted to add something in the first discussion, but also on the second one. So basically, I think that one possible way to find a solution toward this problem is, so one of the three suggestions that I would propose would be, first, to really define the problem that we are looking at, like what kind of emotion or what kind of behavior we want to monitor, and then to try for that behavior, for the different constructs that define the behavior, to try to find the appropriate sensor that could help us, for example, to measure the behavior. But then the second one would be that maybe we could also try to keep also the user in the loop. So let's say in the beginning, we could have a very immature model, which would get feedback constantly from the user, and then of course, using the self-reports, and then also improve itself through active learning. And also the third point would be that maybe to make sure that we are collecting good quality self-reports, to add data from other sources, so more contextual information from different sensors, but not only one sensor.
Very nice. Anybody else?
Can I?
Yes.
Yeah, so I want to pick up with Jamie's idea. Is quite subjective, also not so observative. So I work with a psychology professor in our institute, and I think that really opened our eyes. So for this emotion, so there are studies in the psychology and neuroscience that the subjects are exposed to emotional stimuli, and then they measure the EEG, and then they look at the facial expression and have professional certified facial expression coders to decompose their facial expression and classify it back into their emotion. So from some of these studies, just from the EEG to their facial expression is not 100% correlation. So this is already one layer of uncertainty. And also for this engagement or cognitive load, so in psychology, they use this benchmark test, and they close the people in clean rooms and play MBAC tests with them. And at the meantime, measure their EEG. And even under these conditions with high precision EEG instruments, these accuracy under different MBAC levels and different cognitive intensities, the accuracy they can achieve is quite low than what we are used to in computer science and activity recognition. So I think we really need to be careful when we say have a really high accuracy, because maybe we're just looking at the physiological changes. And this physiological change may be caused by external stimuli or external condition, not our own, our brain. So I think it could be helpful that our community work with more of people from psychology or neuroscience in this regard. Yeah.
So let me actually keep pinching on different situations about emotions. So when Jamie said we may never get it right, we don't, humans don't get it right. Are we really good classifiers of emotions? I don't think so. Who's a great classifier of emotions here? Who can see anybody and say I know exactly what you're feeling, right? Psychiatrists spend 20 years trying to discover what are the actual emotions of a patient to try to see, guess what is the therapy that they should perhaps make it work. So I think we should also embrace ambiguity, right? And multi-class type of approaches. This single class type of approaches is a bit dangerous, right? I mean, we're trying to classify a single emotion based on what about just saying we have this weird situation here where the guy is kind of crying but also smiling at the same time. What do we do with that? Maybe we just formulate theory at the beginning, but it might be useful. What about multi-classification, ambiguity, embracing ambiguity in this kind of signals? Should we do something about that? What do you think, guys?
I think this comes down to the application you're trying to define. If we're building an application that wants to try and detect a specific emotion, we're probably not going to succeed. But why do we want to build that application? Let's go back to what we're trying to do. And if we can use the ambiguity to help us build new things, that would be really cool. What those are, though.
Where those are. What if you can find, go ahead, somebody else, go ahead.
Just want to throw in basically just piggybacking on that previous comment on using perhaps crowdsource judgment to evaluate. And this is actually kind of like a standard approach in other fields like information retrieval, for example, when one of the main issues we have in our community especially is actually we often just work with small set of participants. So I guess either some of our findings may not be easily generalized to others. So I wonder if, let's say, if there is a study, really large scale on all these different, I mean, this is another question rather than a comment, really. And I wonder if one, even maybe if all of us here collaborate on one particular project, and Mirko and his team does this object detection, and somebody's doing the fMRI is doing that. Like we combine all this multimodality, and we collect this data from all over the world, wherever we are. Okay, from North America, from Europe, from Australia, and I wonder if there is really very much difference in within subject and across subjects, and whether the personalized model is always the best, or whether we can draw some generality across the different persons. So. It's a question for everyone.
I think we should do that. Physics do that. Chemists do that. We are not sharing our data.
I think this really depends on the depth or the granularity of emotions that we want to detect. So if we're only looking for like very high level things that we can easily classify in 4 different buckets, then maybe this general model could be possible. But as Pablo mentioned, there are also emotions where you're smiling and crying at the same time. And even for a specific person, the emotion and the representation of emotions are going to be changing over time as well. So the same emotion reaction that I have today is not necessarily going to reflect the same emotions that I have tomorrow or yesterday. So it might be very tricky to actually come up. It would be great, but it might be very tricky to come up with a global model that is very fine-grained, that can classify and be applied to many different applications.
Yeah, I actually wanted to throw here another multi-thing, like multi-domain, right? Multi-model is one thing, but multi-domain, there's this like approach in machine learning called distribution shifting. Like you plot a distribution of somebody, and that distribution can shift over time, right? What you're saying, right? Maybe because you're getting older, or maybe because the weather, or maybe because whatever it is, right? And those distribution shifts are meaningful, right? Because if you're using some kind of like, detection of some kind of meaningful detection will be like, I feel like, we should also discuss the multi-domain. What do you feel about this like distribution shifting multi-domain? I'm talking about within the same subject, not necessarily across populations, right? Do you think this is something that we should also consider, or how can we approach this type of like problems?
This is tying into having the complete context of your life, like having all of your history and everything that happens to you. It's just trying to understand absolutely everything, not just activity, not just location, but your thoughts and feelings. It's absolutely everything. Once we have everything, then we'll get a good emotion detector. So we're nearly there.
This is scary, but as Jamie mentioned, this is really about putting your entire life into a computer and having sensing modalities all around you, trying to capture every aspect of your life, trying to diagnose what you're feeling. And man, this is not only difficult, but this is really scary.
All right, so let me poke another thing. Like, okay, this is a sensing discussion, and I love sensing, but let's talk about interventions for a second. Like, we're sensing for some reason, right? I mean, why are we sensing? Like, I mean, I will imagine it's because we want to generate policy or treatment or something, right? Otherwise, why are we measuring so many things, right? I mean, there must be, well, we can say theory also, sure, just for the sake of measuring. Sure, we can do that too. But, many of us are doing health, and we're trying to do like some kind of health outcome. Like, what if we forget about labeling the sensors, for example, and we just take the sensor and pass it directly to the intervention layer, and like we just find the best intervention for the combination of this multimodal, multi-domain, but we don't have to label the sensors, right? We don't have to say that's anxiety, that's whatever. Like, what if we study that loop directly to the intervention layer? Or do you think we really always need to have an ontology for sensing before we really do proper like intervention? I'm just throwing a curveball here to see how some people react.
Well, this really goes back to the ground truth issue, right? I mean, if we have a really good ground truth for a specific time that's perfectly time synchronized with the sensing modalities, then maybe we could, you know, find new biomarkers, right? We could identify new hints on different events that are happening physiologically or emotionally using just time series sensor data. But if we don't have this information, my concern is that it might be considered just random jitter in most of the cases because of the sensing noise itself and because the lack of expertise to elaborate from these signals.
There is also a question about potentially safety in this domain. So I think certain application might allow us to do sort of like adaptation, experimentation using the streams of sensors. But I would say that there is a question here about really safety in terms of which kind of intervention you show. And also, yeah, and there is also this question that I think is quite interesting that is related to personal differences that that is also there. So it is an aspect that we discussed about like multimodality, but so if you build a model also one type of intervention might not work for everyone. And this is the thing also related to the fact that you might not want to have a general model, but you might want to have some theory or something that is validated in order not to harm. Because I think that so especially so one thing that I always say, that there was also a workshop on mental health a couple of days ago. So one thing that I always think about is that it's extremely hard to do like behavioral intervention, for example, for depression, using this type of information, because you might really put people in danger. So, I mean, we don't know. I mean, so the fact that so usually a behavioral intervention is done typically in a room with a specialist, or you have other interventions that are like web intervention that again they're quite generic and so on. If you do something with a phone and you are really reaching the person in their place, right, in a context that may be complex or difficult for the person, I think that is potentially harmful. So I think there is also that we should consider. So like running this study, I think that is something, when you say like the census, yes, we should try, but like doing trial and error here might be problematic for certain type of condition. Okay, other things you might try. I mean, other things are like, I don't know, like lifestyle changes. Right. Even if you make mistakes, it's fine. So maybe a person is not doing like a lot of I don't know, activity following your intervention is okay. But something that might have might become a sort of a danger for the person, that is problematic, I think.
So what if we don't do treatment, we do prevention, right? What if we focus on the precursors to depression, right? You know, you start waking up late, you start not doing your job, you start like not talking to people. And if you ask them to do more of that, more or less of that, you can fail a little bit what you're saying, right? So maybe, you know, one very interesting area of research for you becomes not so much on the treatment side, as on the prevention. We could discover the relationships between personalized interventions and personalized sensing, and basically keep people like on the hygienic model of mental health, right? You're doing hygiene, right? Hygiene, as opposed to like treatment. What do you think about this idea of hygiene? Like, you know, should we do hygiene for like, you know, mental health using ubiquitous computing, right?
That is interesting. The question is like, it's very difficult to measure like at individual level. So your prevention intervention usually are done at population level because you can measure. Right. Yeah, but still you might do at community level. So the community level can be done in a school or in a community, and that might be something measurable. So you need to do something measurable for prevention, and I think it is possible, because at the end of the day there are some intervention that are prevention intervention that are quite okay. So like I don't know, insurances, that give, I don't know, sort of Fitbit like or this type of wearables for improving, for increasing activity. And these are indirect interventions, very simple ones, but you can measure then some factors like less, the number of day off in a company might go down. So there are things that you might be able to measure.
All right. All right. I'm gonna have to give some time for the audience to ask direct questions as well. I think this conversation is fascinating, and I would love to have a long coffee with all of you. But please, audience, raise your hands and ask live questions to the panelists if you don't mind. You can also upvote questions in Hoba if you want to get a question to be asked. So let's hope that there is some people who are interested. Don't feel too emotional. Just ask the question. I don't see anybody else. Oh, here's somebody. Mash is raised the hand. Good. So there we go.
Everyone. Hey everyone. So yeah, I'll ask an unemotional question, based on the discussion that had. So I think I really like the discussion around detecting perfect emotion. But I mean, this kind of question arise in AI, right? People want to build this most intelligent system, try to mimic human brain, and it just never happens, right? So the question here is that do we really want to have perfect emotion detection to build really smart system that can support emotional problems or depression, things like that?
Okay, somebody from the panel. So we want perfect emotion detection.
Yes, we do, and it's scary at the same time, I think. I mean, understanding the human, right? I mean, understanding how we feel as we perceive different events on a daily basis is something that lots of ubiquitous computing researchers are dreaming about. And this itself, just by knowing this information itself, is going to enable lots of interesting applications, right? I mean, I'm not sure if you are a fan of the Big Bang Theory, but I remember an episode in the Big Bang Theory where Sheldon, he just can't pick up sarcasm and emotions, and he takes this device from MIT, and if he points to a specific person, it tells you if the guy is angry or sarcastic or things like that. I mean, I think there are many ways that we can use this information. It's just that if you ask for the need for such technology, I would argue yes. If you ask about the feasibility of having such technology, I'm pretty sure other experts can answer much better than I can.
All right. Speaking of my internet's failing here, so might be the fires or whatever it is here in California. Okay. Anybody else wants to pitch in on that? And are there any other questions? People, raise your hands, please. We're not measuring your emotions. Just do it. Raise your questions.
Hello, can you hear me?
Yes. And Nabil, go ahead.
Okay, I'll assume you guys can hear me, although I can't seem to hear you. But I actually posted a question regarding interpretability, and these are really interesting talks. However, a lot of times a lot of the approaches seem to be very similar, right? Where we sort of apply a machine learning model to predict a specific outcome. And then we're thinking about sort of how this is going to augment self-report or how we're going to learn from these machine learning models. And so my question, I guess, to the panelists is do we really think this is going to see the limelight unless we sort of approach it a different way and really begin to think about using or think about interpretability when it comes to our machine learning models?
All right, panelists, this is your last chance to answer. I don't think there will be too many questions.
And now I can't hear you.
Can you hear us, Nabil? We heard your question about interpretability. I'm sure some panelists want to like jump to that question. Very important.
Yeah, I guess I think that it is very important to do this interpretably, and there are actually a huge spectrum of different machine learning, deep learning techniques in terms of the interpretability of these models, and you know, as we know, the deep learning ones are harder to interpret. But since we are actually collecting a lot of context information in this community, and you know, readings across time, I think this should actually help. The multiple context point of view could actually help us to understand if we can actually understand the feature importance, like in non-traditional machine learning models, and do something actually similar. Also, even if you're trying to do deep learning, you can also perform some kind of like joint learning, and do that within subject and across subjects. We hopefully can tell us how the model perform. But the problem is, I think you are asking a deeper question here. Sometimes, as there is no perfect way of measuring the ground truth or the gold standard, sometimes we have to ask ourselves whether our models actually overfit to the kind of reading we want to the kind of ground truth we want to see. So this is again a question to everyone. So it's more like, again, another comment.
Okay. So it seems like we're out of time, but yeah, there's one more comment. We can like wrap it up with that one.
So just really short, I think this psychology professor that I work with, when we explained the deep learning model to her, she literally said, how do you, human brain is a black box. How do you use one black box to explain another black box? So I just want to put it there because I really like her quote.
I think that's called anthropology too. All right, so guys.
Or mathematics.
Or mathematics, yeah, or
yeah, logic. So we have
right.
philosophy. So we have
or philosophy, right? Or theology, or any of these other.
Theology, yeah. Metaphysics, yeah.
They are black boxes explaining other black boxes.
yes.
So thank you so much. I think this was fascinating. The time's over. There is some other questions on Huba directed to some of you directly. Please follow up with those people who have been asking these questions. Again, I would really like to extend this conversation as long as possible, but time's over, and I'm respectful of your time, especially in other time zones. Thank you so much to all the panelists. Thank you so much for everyone for this great discussion.
Thanks, Pablo, for chatting. Thanks.
Thank you, Pablo.
Bye. See you guys.